All right, so just to say what Ray is, you can think about 3 different layers to Ray. In the middle, there's the core system, which is essentially scalable Python. Right? You know how to program in Python on your laptop. Ray lets you take Python code and build Python applications that run across clusters of machines. Okay? Then on top of the core Ray system, there's an ecosystem of scalable libraries for machine learning. So this is things like I want to train my deep learning models. I want to deploy my machine learning models. I want to ingest my data, pre-process my data. Right? I want to do batch inference, hyperparameter tuning, reinforcement learning, all of these kinds of things. So there's off-the-shelf libraries that you can use for building scalable machine learning applications. And then underneath Ray, you can run Ray anywhere. You can run it on your laptop, pip install it, or you can run it on any cloud provider. You can run it on your Kubernetes cluster. You can run it on any scale. Right? So any scale is the platform we're building. It's the best way to run Ray. And so all of this I've just described is open source, and you could download it and try it out right now. Okay, so to give you a sense of the kind of ways that people use Ray in any scale, the types of problems that people solve, Ray is extremely general in the same way that Python is extremely general. And you can solve any problem with Python. But the main use cases that we see people using Ray in any scale for are things like training your deep learning models, training your machine learning models, serving, like deploying the models, and as well as doing batch processing. Okay, and the way, the types of problems people use them for, and this meetup is about LLMs. Natural language processing is one of the primary use cases for Ray. So is computer vision. Okay, so there are other, and there's a long tail there. You can use Ray for any kind of data or problem that you have. But on the natural language processing side, I mentioned OpenAI is a good example. Cohere, if you're familiar with Cohere, uses Ray to train their models. If you're familiar with open source LLMs like GPT-J, that's trained using Ray. So Ray can, like LLMs are so compute intensive and require, tons of GPUs, CPUs. There's a huge amount of infrastructure that typically has to be built to scale the training and inference and deployment of these models. And if you're using Ray, Ray essentially handles a lot of those problems for you. So just to say a few words about the value that Ray is adding and Anyscale is adding if you're using it. There's 2 different dimensions here. One is about just not having to build the infrastructure yourself, right? Ray and Anyscale provide that infrastructure. It's being able to easily train these models, deploy these models without having to think about configuring clusters, setting up large clusters of machines, things like that. And then the other dimension to it is performance. It's being able to train it faster, train it at a larger scale, train it in a more cost-efficient way. I'll give you a few examples of what our platform looks like. So these are a few screenshots. So this is, first and foremost, Anyscale provides managed infrastructure so that in the same way that GitHub is a managed service for Git, you don't have to manage your own Git repositories. It's providing that managed experience, so it works for you out of the box. It's providing a great interactive development experience. There's a few main concepts that Anyscale provides. It's like the tools for interactive development. It's the tools for submitting batch jobs for things like training or data processing, and tools for deploying services or deploying models that you can query. Of course, if you're training these LLMs, a big problem you're going to run into is debugging. You're going to run out of memory on some machine. You're going to run out of GPU memory on some GPU. Do you have the tools you need to be able to diagnose what went wrong? And if you've diagnosed what went wrong, can you understand what to do about that, how to fix it, right? So a big part of developer productivity in the distributed setting is about essentially having the observability into what is going on so that you can debug more efficiently. Okay. So lastly, I want to share a few examples of how people are using our stuff. So I mentioned Uber. So there's many use cases of deep learning within Uber. One example is for ETA prediction. So I'm sure many of you actually took an Uber to get here. Okay, so Uber, if you get in an Uber, it tells you the ETA, like what time you're going to arrive. They use a deep learning model called deep ETA to generate that prediction. So the way they were doing this previously was they built a distributed system called Horovod for scaling deep learning training on GPUs. Now, as they were scaling training on GPUs, they became bottlenecked by their ability to ingest data and pre-process that data and feed that data into the training. Okay, now Horovod it's a distributed system for scaling training on GPUs. It doesn't provide a way to scale data ingest and pre-processing. They had Spark for data ingest and pre-processing, but that was an entirely different system. And there was no good way to combine them together without building a lot of surrounding infrastructure. So what they ended up doing was porting all of this to Ray, running their training by running Horovod and scaling deep learning training on top of Ray, and then scaling the data ingest and pre-processing with a different Ray library called Ray Data. So they were able to scale the data ingest and pre-processing on CPUs with Ray Data, scale the deep learning training on GPUs with Ray Train, pipeline them together for performance reasons because it's all part of a common system. And from the infrastructure perspective, this is far simpler for the team to manage because there's a single system that you're managing. It's just Ray. And in fact, one of the things they value about Ray is just the fact that it provides common infrastructure for all these different workloads. And from the developer perspective, instead of learning how to use Spark and then Horovod and how to build all the glue to stitch these things together, they're just learning how to write a Python script, importing different libraries and using them together. So this is why Uber decided to go with Ray, and it's a similar reason for Shopify, Spotify, DoorDash, many of these other examples. I think the one that's most relevant, and this is the last one I'll share, is OpenAI. So OpenAI has also gone through multiple generations of building infrastructure and distributed systems for scaling their machine learning applications. In fact, so OpenAI started in around 2015, and Ray didn't exist at that time. But we knew a lot of the OpenAI people from early on, and and so they actually tried out Ray fairly early on before it was very good. And actually at that point when that happened, it didn't work out. They decided to go down a different path and build their own infrastructure, build an infrastructure team. They built a lot of their own distributed systems combining tools like Redis and MPI and other RPC frameworks. And that's what they did for the early Dota results and so on. But OpenAI is really pushing the limits of scalability, in terms of number of machines, number of GPUs, things like that. And so even though they built their own infrastructure already, they kept having to rebuild it and kept having to, as they were scaling more and more, they got to the point where they were going to have to throw it all away and build something new anyway. And at that point, they started looking around and realized that actually, if they used Ray, it could save them a tremendous amount of work. They wouldn't have to build that infrastructure team to invest all of this energy on building distributed systems. And so they ended up using Ray for scaling their training workloads for many different reasons. Things like at a large scale, it's fault tolerant, right? So you can handle machine failures. That's increasingly important as you get to a larger and larger scale. So there are a lot of reasons. Developer productivity is another reason. Just being able to iterate quickly and run experiments quickly. So there's a common thread with many of the other companies choosing to use Ray. It's a similar story for Cohere and for the folks training GPT-J. So the last thing I want to say is if you're interested in, there's a lot more use cases I'd love to tell you about. But if you are interested in learning more about Ray, we are having our Ray Summit in September. This is our annual in-person Ray conference. Actually, last year was the first in-person one, and that was where Greg from OpenAI was talking about how they use Ray. But there'll be a bunch of companies, Cohere, OpenAI, talking about how they use Ray for LLMs at the Ray Summit this year. A lot of other thought leaders in AI people pushing the boundaries of deep learning. If you're interested in essentially learning what all these companies are doing and how they're using Ray, I encourage you to register. We're also running training sessions, so actually teaching people how to use Ray for things like scaling training, whether that's LLMs, as well as things like serving and other aspects of just the whole ML lifecycle. So would encourage you to check it out. It's nearby here in San Francisco. All right, I'll stop there, but enjoy the meetup. I think it's got a lot of great talks lined up, and enjoy the event. I'm happy to take any questions, but also happy to hand it back to you. Yeah.
Thank you.
Nice sketch, guys. Who wanted to ask a question? Here you go.
Really simple. Was that supposed to be a link up there? Because I can't really see anything. Oh, it says registration is open, but is there a QR code or what? How do we get to that, essentially?
If you Google Ray Summit 2023, sorry about not having the link. We'll send the link out afterwards, but if you Google Ray Summit 2023, it'll come up. Yeah.
Yeah, just a quick one. Have you actually looked into yet refactoring any of your algorithms to be quantum native?
Have we looked into refactoring any of our algorithms to be what?
Quantum native.
Cloud native? Is that what? Quantum. Oh, quantum native. We haven't, no. But we do, one thing that is really important for Ray is to be able to leverage all the best hardware accelerators out there. GPUs are the obvious ones, but TPUs are extremely important. And a lot of these results, like Cohere and GPT-J, were trained using TPUs. And the same applies for other accelerators as well. So one of the nice things about Ray is that it can make it easier to write, distributed applications that use a variety of different hardware accelerators. So, and I think if you're using, as there become more and more accelerators that are like quantum in nature, Ray will be able to take advantage of those as well.
Hey, thanks. So quick question. Can you summarize where is the end of the open source Ray and the beginning of AnyScale platform?
Yeah, great question. So where's the end? So what's the difference between Ray and AnyScale, right? So Ray is the open source project. It's like the runtime. It's the Python library you can import and use to build the distributed application, okay? Where you run into challenges as companies start to have, so it's easy to use Ray, okay? You can download Ray and use it on your laptop, set it up on a cluster. Where you start to have challenges is when you go from, a few developers using Ray to maybe larger teams collaborating and using Ray, or you have a few Ray clusters, one or two, to having, dozens or hundreds of Ray applications, running, or you go from a couple models in production to trying to deploy hundreds of machine learning models in production. So these are some of the things where teams like, we mentioned Uber and so on, start to need to build additional tooling around Ray, right? They need to build additional infrastructure for collaboration, for managing this, the services, for things like I ran some Ray application or trained some model a month ago. Are all the logs persistent? Can I go back a month ago and look at what I ran and click a button to reproduce it, or share it with my coworker and then they can modify it and reproduce it and things like that. So those are all the things you get with a managed service that AnyScale provides. And that would be hard to implement as just an open source project. There's additional dimensions too around security, around in some areas, because we're running a service, we're able to provide better performance for things like cluster startup time and auto scaling. But hopefully that answers your question.
Thanks.
Yeah.
Anyone else have any questions?
Thanks. How do you position yourself, for instance, against Databricks, for instance?
How does it relate to Databricks?
I mean, how do you position yourself? Because you're both, have an open source part, have enterprise, a lot of full all the steps and so on. How do you see yourself
Yeah, so
different?
how do we position ourselves relative to Databricks? That's the question, right? So great question. So I'll talk about Databricks and actually, SageMaker is perhaps another interesting comparison point. So SageMaker provides an end-to-end machine learning platform, okay? So this is things like training, serving, and so on. And in some ways, they do more things than we do, right? Because they also, in addition to training your models and deploying your models, they also do experiment tracking, right? They have good UIs for visualizing progress in your experiments. They have model registries for storing your models, versioning your models. They have feature stores for storing your features and serving them. So there's a lot of different pieces, right? What we're focused on with Ray and Anyscale is really the compute piece. So being the absolute best way to manage and scale compute for things like training, serving, those workloads. So where we differentiate ourselves is, on performance, is on developer productivity, things like that. But when it comes to all of the surrounding parts of the machine learning lifecycle that, like your feature store, model registry, experiment tracking, we don't build that. Instead of providing the one-stop shop for that, we integrate with all the other tools out there. So you can, if you're using Anyscale and Ray for training your models, you can use that along with weights and biases, or along with MLflow, or along with the SageMaker model registry, like these kinds of things. Yeah.